Everything you learned about the early universe, that it started as a thin soup of hydrogen and helium, that heavy elements like uranium and gold took billions of years and generations of dying stars to cook up, might be completely backwards. What if the very first moments of the cosmos produced uranium directly, not through fusion, not through supernovae, but through geometry itself? Today on Copilot Podcast, we're diving into a framework called KT Cosmology, laid out in a document called earthformation.bdl, and we're going to unpack three things: what curvature torsion cosmology actually claims, why it thinks the standard model is cracking under its own contradictions, and what the hyperperiodic table even means. By the end of this, you'll have a genuinely different picture of how the universe's chemical complexity got started. I've got someone here who has gone deep into this material, so let's get into it. Walk me through what's actually broken in the standard model first.
So the document opens with a pretty direct claim. The ACDM model, that's the lambda cold dark matter model, the standard cosmological framework, is collapsing under the weight of its own contradictions. And it lists specific cracks: the Hubble tension, DESI's evolving dark energy, JWST's early galaxies, and statistical anomalies in large-scale structure.
Right, and those aren't fringe complaints. The Hubble tension is a real documented disagreement between different ways of measuring how fast the universe is expanding.
Exactly. And the argument in earthformation.bdl is that these cracks are not random, they're directional. They point toward a deeper geometric structure that ACDM simply doesn't have the tools to see. So, the reconstruction being proposed replaces the cosmological constant with what it calls a curvature-torsion dual field.
Okay, so before we go further, curvature and torsion, those are real geometric concepts, but I think most people hear those words and their eyes glaze over. What are they actually doing in this framework?
So the core claim is that curvature and torsion are orthogonal eigenvectors of cosmic geometry. The document uses the notation K for torsion and T for curvature, and it says they are not derived quantities, they are the generative basis of spacetime. Curvature acts radially, governing metric expansion, geodesic separation, radial displacement. Torsion acts tangentially, governing angular twist, circulation, and quantized action.
So like two rails running perpendicular to each other.
That's exactly the language the document uses, two rails, and the universe evolves along both simultaneously. The product of these two fields, K times T, is what generates spacetime itself. The equation is literally universe of T equals K of T times T of T. Everything, expansion, structure formation, acceleration, deceleration, is a projection or function of that product.
That's a bold claim. One equation for everything.
It is. And the framework goes further by assigning general relativity and quantum mechanics to these two separate rails. GR lives on the curvature rail, radial, smooth, energy conserving. QM lives on the torsion rail, angular, discrete, momentum conserving. The document argues that Einstein's unification problem was never about merging the two theories into one. It was about recognizing they were always orthogonal components of the same geometric engine.
Wait, so the argument is that GR and QM don't need to be unified in the traditional sense. They're already coexisting, just on different geometric tracks?
That's the claim. And the document uses what it calls an Euler topological filter to enforce this. The filter restricts admissible geometric cells to manifolds with Euler characteristic equal to 2 or 0. Euler characteristic 2 gets assigned to curvature domain cells, sphere class, simply connected, radial, energy conserving. Euler characteristic 0 gets assigned to torsion domain cells, torus class, looped, angular, momentum conserving.
So energy conservation is literally a sphere geometry thing, and momentum conservation is a torus geometry thing.
Exactly. The conservation laws become topologically encoded. Energy cannot leak into torsion, momentum cannot leak into curvature. The rails stay orthogonal, but their product remains generative. And then Planck's constant enters as the quantized coupling between the two rails. The document writes it as the change in torsion domain action being equal to n times h, where h is Planck's constant.
So Planck's constant isn't just a quantum mechanics thing in this picture, it's the bridge between the two geometric rails.
Right. The document calls it the first true coupling between GR and QM, and it emphasizes that this coupling is geometric, quantized, and non-perturbative. It doesn't require renormalization, extra dimensions, or exotic fields.
I want to push on this a little because there have been a lot of attempts to unify GR and QM, string theory, loop quantum gravity, all of them. What makes this different from those?
The document's answer is that every previous attempt failed because each approach tried to force both theories into a single mathematical domain. Einstein tried to geometrize electromagnetism. Quantum theorists tried to quantize gravity. String theorists tried to embed both into higher dimensional manifolds. The argument here is that all of those failed for the same reason. GR and QM do not share a common geometric substrate. This framework doesn't try to merge them. It assigns them to separate substrates and lets their product do the work.
Okay, so now let's get to the part that genuinely surprised me when I read through this, the hyperperiodic table, because this is where it gets really wild.
Yeah, this is the section that reframes everything we think we know about where heavy elements come from. So in the standard model, elements heavier than lithium are made in stars. Uranium, thorium, the actinides, those require neutron capture processes in supernovae or neutron star mergers. It takes billions of years and multiple stellar generations.
Right, the classic story, we are stardust, all of that.
And this framework says that story is incomplete at best. In the earliest universe, the torsion generator overwhelms the curvature generator so violently that the tangent direction, which the document writes as the partial derivative of k with respect to t, becomes the dominant dynamical axis. And when that ratio exceeds a critical threshold, something extraordinary happens to nuclear physics.
What happens exactly?
The document calls it Gibbs collapse. The Gibbs structure of the substrate collapses under torsion curvature compression. In standard nuclear physics, heavy elements require multiple fusion steps, neutron capture, slow R process pathways. In this geometry, those steps are bypassed entirely. The potential barriers that normally prevent the formation of high Z nuclei with large atomic numbers, get flattened. The tunneling probability becomes order unity. Nucleonic configurations jump directly into heavy element basins.
So the barriers just collapse, and nuclei that would normally be forbidden can form spontaneously. That's the claim. And the document formalizes this with what it calls the tunneling threshold theorem. There exists a critical value of that torsion curvature tangent direction.
Below it, the effective barrier remains finite, tunneling is exponentially suppressed, and nucleosynthesis proceeds through classical fusion. Above it, the barrier collapses to what the document calls an infinitesimal residue, and the tunneling rate saturates to order unity. Heavy elements form with probability 1 on the substrate timescale.
And these are the hyperperiodic table elements. Exactly. The document defines a hyperperiodic table element as a nucleonic configuration formed in a region of what it calls the typed interior, where that torsion curvature tangent direction exceeds the critical value, driving the substrate into a tunneling-dominated phase. These elements occupy generator points in the torsion curvature plane with large positive torsion exponent and strongly negative curvature exponent. And critically, they include nuclei with Z greater than or equal to 92 and super-heavy protoisotopes beyond the classical periodic table.
So uranium, thorium, the actinides, all of those arise directly from the geometry of the early universe, not from stellar processes.
That's the argument. And the document is explicit about what this means for temperature. It says temperature in this regime is not a thermodynamic variable, but a geometric consequence of torsion amplification. The observer frame temperature scale is, in its words, merely the shadow of a deeper phenomenon. The substrate is driven into a state where tunneling barriers evaporate and nucleonic configurations jump discontinuously into high Z basins.
That's a genuinely different way of thinking about heat. Heat as geometry, not as particle motion.
The document calls it geometric heating. It arises when torsion outruns curvature in the early manifold, producing an effect analogous to directed thermal input, even though no thermodynamic processes are involved. It uses the phrase geometric blowtorch, a focused curvature torsion compression that elevates effective temperature according to a proportionality with that tangent direction ratio.
Okay, so I want to connect this to something concrete because this is where JWST comes in, right? Because JWST has been finding things that don't fit the standard model.
This is where the framework gets its most direct observational grounding. The document dedicates an entire chapter to reinterpreting JWST observations through KT cosmology. JWST has detected metal-enriched gas at redshifts greater than 7, dust reservoirs in what should be chemically primitive galaxies, solid grains, iron, silicon carbide, polycyclic aromatic hydrocarbons in early systems, and massive galaxies at redshifts greater than 10 that are far too chemically evolved for the standard model.
And under ACDM, those signatures require multiple generations of stars and supernovae, which takes hundreds of millions of years minimum.
Right. Under ACDM, you need time, lots of it. Stars have to form, live, die, explode, seed the next generation, and repeat. But under KT cosmology, the document argues that enrichment is primordial. The earliest galaxies inherit heavy elements directly from the substrate's geometric dynamics. The hyperperiodic table is not an evolutionary endpoint, it's an initial condition.
That's the inversion that really got me. We've always told the story as simple beginning, complexity builds over time. This says the universe started geometrically complex.
And the document makes that point explicitly. It says the earliest galaxies are not primitive. They are born from a substrate that has already undergone a phase of extreme torsion-driven nucleonic tunneling. The hyperelements are, in its words, the fossils of that phase. The residues of a universe that began not with hydrogen simplicity, but with geometric complexity.
So what happens to these hyperelements after they form? Do they just stay put?
No, and this is where the framework gets into some really interesting dynamics. As the universe expands, curvature begins to catch up with torsion. The tangent direction decreases toward unity. The tunneling phase ends. Heavy elements produced in the early era accumulate in what the document calls toroidal rings surrounding forming black holes. These rings become reservoirs of hyperperiodic nuclei.
Toroidal rings around black holes, like donuts of uranium.
Essentially, yes, and then the curvature vector activates. The document describes a condition where the curvature vector extends centrifugal acceleration radially outward from the outer edge of the toroidal ring. This destabilizes the ring and initiates what it calls mass shedding. The outer edge becomes a launch surface.
A launch surface, so these heavy nuclei get ejected.
Through what the document calls escape velocity sorting. Hyperperiodic nuclei experience inward gravitational pull, outward centrifugal acceleration, and outward curvature extended acceleration. The net force ejects heavy nuclei from the ring. Their trajectories are determined by their split velocity relative to escape velocity. Some end up in bound orbits within the torus or halo. Some become marginally bound extended shells, and some go on unbound trajectories into interstellar or intergalactic space.
And those unbound ones, what happens to them over cosmic time?
This is the part I find genuinely fascinating. The document says unbound hyperelements drift into the cosmic medium as gravitational seeds. Their extreme rest mass and torsion compression history give them disproportionately strong local gravitational fields. Over millions to trillions of years, these seeds accrete hydrogen, helium, dust, metals, ices, and dark matter streams. The result is the formation of rogue planet mass condensates in interstellar and intergalactic space.
So planet-sized objects that didn't form in any solar system, just drifting through the void, nucleated from the geometry of the early universe.
And the document is specific. These bodies do not form in protoplanetary disks. They nucleate directly from curvature-driven accretion around hyperperiodic seeds. It's a completely different formation pathway from anything in the standard model.
Let's talk about the 3 epochs, because the document structures cosmic history in a very specific way that I think helps organize all of this.
Right. The KT Rails diagram, which is a central visual in the document, shows the evolution of torsion K of T, curvature potential T of T, and Gaussian curvature across cosmic time. 3 epochs emerge from this. The early epoch runs from 0 to about 4.67 billion years. That's the torsion-dominant ignition phase, high torsion gradients, geometric heating, nuclear barrier collapse, primordial heavy element formation.
So the first 4.5 billion years or so are this wild torsion-dominated phase where the universe is basically a geometric forge.
That's a good way to put it. Then the middle epoch runs from about 4.67 to 9.33 billion years. That's the curvature structuring phase. Curvature grows relative to torsion, enabling what the document calls baryon cycling and mass redistribution. This is where the toroidal rings form, where curvature-driven ejection happens, where large-scale structure organizes.
And the late epoch is where we are now.
The late epoch runs from about 9.33 billion years to the present at roughly 13.8 billion years. The document calls this boundary-neutral stabilization. Curvature potential drains, torsion gradients collapse, and interior expansion ceases. Cosmic acceleration in this picture arises from boundary-only expansion rather than dark energy.
Wait, boundary-only expansion. That's a big departure from ACDM. Explain that.
ACDM assumes that space expands uniformly everywhere. The interior of the universe is expanding. KT cosmology rejects that. The interior manifold does not expand. Instead, cosmic growth occurs exclusively at the outer boundary, which the document describes as a finite closed horizon at approximately 13.8 billion light-years. The interior remains static, preserving density and enabling rapid gravitational collapse.
And that's why early galaxies could form so quickly and reach such high masses, because the interior isn't diluting.
Exactly. The document says this geometric condition eliminates the dilution effects inherent to ACDM, allowing early galaxies to form quickly and reach high masses without requiring extreme star formation efficiencies. JWST's detection of massive galaxies at high redshift is, in this framework, a natural consequence of boundary-only expansion.
And this connects back to the Hubble tension. Directly. The document's argument is that the Hubble tension is not an anomaly and not a measurement error. It is the expected signature of a dual-field universe where interior measurements and boundary expansion rates are fundamentally different things. Local measurements don't track boundary expansion, so you get discrepancies between local and cosmological determinations of the Hubble constant. ACDM has to introduce new physics or invoke systematic errors. KT cosmology says the tension is built into the geometry. That's a striking reframe. The tension isn't a problem to be solved, it's a prediction.
That's precisely how the document frames it. And it goes further with a set of concrete, testable predictions. It predicts widespread actinide signatures, Z greater than or equal to 92, in high redshift systems. It predicts early dust reservoirs containing hyperperiodic nuclei. It predicts metal-enriched outflows at redshifts greater than 10 without prior stellar generations.
So JWST should keep finding chemically mature galaxies at epochs where ACDM predicts pristine composition.
That's one prediction. Another is abundant galaxies with masses between 10 to the 9th and 10 to the 11th solar masses at redshifts greater than 12. Early black hole seeds exceeding 10 to the 6th solar masses. High-velocity enriched gas greater than 100 kilometers per second without supernova feedback. And toroidal heavy element rings around early black holes.
Those are specific enough to actually test, which is important, because a framework that can't be tested isn't really science.
The document acknowledges this implicitly by framing these as predictions for future JWST, ALMA, and ELT observations. The framework is positioning itself as something that can be confronted with data.
I want to go back to something you mentioned earlier. The document also introduces what it calls the NSP Mod 4 saddle layer. That's a piece I found harder to follow. What's the role of that?
So NSP stands for non-standard physics in the document's terminology. The saddle layer is a region where curvature and torsion gradients align in a neutral configuration. It enforces what the document calls dual-channel conservation. The change in energy modulo 4 equals 0, and the change in momentum modulo 4 equals 0. It's a conservation mechanism that's geometric rather than thermodynamic.
And it appears in the KT Rails diagram as the purple region.
Right. The document says this layer produces the neutral condition at the present cosmic boundary, curvature potential drains to 0, torsion gradients collapse to 0. This neutralization halts geometric heating, eliminates tunneling, and stabilizes the boundary. And it connects to JWST observations of large-scale coherence and uniformity in early structures.
So the saddle layer is essentially the universe's off switch for the hyperelement forge.
That's a useful way to think about it. Once the saddle layer condition is reached, the torsion-dominant tunneling phase is over. The hyperperiodic table collapses from its extended form back to the familiar 118-element structure we observe today. The hyperelements decay, fragment, or become locked into early dust grains and protoplanetary structures.
And their signatures remain: anomalous isotopic ratios, unexplained heavy element abundances, early universe metallities that defy classical astrophysics.
The document lists exactly those as the detectable remnants: anomalous isotopic ratios, unexplained heavy element abundances, and early universe metallities that defy classical astrophysics. Those are the fossils of the hypereon.
The hypereon, that's the document's term for this earliest phase, right? It gives it a geologic time unit.
Yes. The document defines the hypereon as the third major KT geologic time unit, spanning the primordial curvature torsion epoch in which hyperperiodic table elements with Z greater than 92 condensed near the earliest galaxies. It runs from cosmic time 0 to approximately 0.3 billion years. The dominant field is torsion. The matter type is hyperperiodic nuclei, and it notes that Earth's deepest crustal bedrock inherits hyperperiodic residues from this epoch, transported through early galaxy formation and KT curvature focusing.
So the claim is that there are traces of this primordial geometric phase literally in Earth's crust.
That's what the document asserts. It's a bold claim, but it's consistent with the internal logic of the framework. If hyperelements seeded early galaxies, and those galaxies eventually contributed material to stellar systems, and those stellar systems contributed material to planetary formation, then yes, the residues would propagate forward.
Let me ask you something that I think listeners are probably wondering. This is a very ambitious framework. It claims to complete Einstein's unification, resolve the Hubble tension, explain JWST anomalies, and rewrite the origin of heavy elements. How does it position itself relative to mainstream physics?
The document is explicit that it is a reconstruction, not an extension. It's not trying to patch ACDM, it's replacing the foundational assumptions. The cosmological constant is gone, replaced by the evolving torsion field. Interior expansion is gone, replaced by boundary-only expansion. Stellar nucleosynthesis as the origin of heavy elements is demoted. It becomes a secondary process that takes over after the torsion-dominant phase ends. And the document does acknowledge that DSI's results, the weakening dark energy signal, fit into this picture. Yes, the document has a specific section on DSI's weakening dark energy as torsion decay. DSI suggests that dark energy evolves, that the cosmological constant isn't actually constant. In KT cosmology, the dark energy operator is defined as the negative of the curvature projection of the torsion decay rate. As torsion decays, curvature becomes dominant, producing early acceleration, mid-epoch stabilization, and late-epoch weakening. The document says DESI's results are the signature of torsion decay.
So DESI, JWST, the Hubble tension, the framework is claiming all three of those observational puzzles are explained by the same underlying geometry.
That's the core argument, and the document frames it as a unified geometric explanation, not three separate patches for three separate problems, but one framework that produces all three as natural consequences of curvature torsion dynamics.
So when you step back from all of this, and there is a lot to step back from, what does this framework actually come down to at its core?
At its core, KT Cosmology is making a claim about what the universe's operating system actually is. The document's language is striking. It says the universe's operating system uses the curvature torsion algebra to generate its Euler-Gaussian prime zeta product field, and that field manifests as spacetime, expansion, and cosmic structure. The cosmological constant is not a fixed background. Dark energy is not a mysterious substance. They are both projections of a geometric relationship between two orthogonal fields.
And the hyperperiodic table is the chemical imprint of the universe's geometric infancy.
That's the document's phrase exactly. The chemical imprint of the universe's geometric infancy. The earliest galaxies are not primitive. They are born from a substrate that has already undergone extreme torsion-driven nucleonic tunneling. The hyperelements are the fossils of that phase, and their existence, if confirmed observationally, would be the clearest signature that the KT manifold is not merely a mathematical construction, but the generative engine of cosmic structure.
Here's what this really comes down to for anyone listening. We have a framework that takes the cracks in the standard model, the Hubble tension, DESI's evolving dark energy, JWST's impossibly mature early galaxies, and says those aren't bugs, they're features. They're what you'd expect if the universe runs on curvature and torsion as orthogonal geometric rails, rather than a cosmological constant.
And the implications cascade from there. If the torsion-dominant early universe really did produce heavy elements through geometric tunneling rather than stellar fusion, then the story of where we come from changes fundamentally. The uranium in Earth's crust, the thorium in ancient rocks, in this framework, those aren't the products of long-dead stars. They're geometric residues of the universe's first moments.
Which means the next time JWST finds a galaxy at redshift 12 that's already full of metals and dust and complex chemistry that ACDM says shouldn't be there yet, this framework has an answer ready. It's not an anomaly, it's a prediction.
And that's the test. The document lays out specific, falsifiable predictions. Actinide signatures at high redshift, massive galaxies at Z greater than 12, high velocity enriched gas without supernova feedback, toroidal heavy element rings around early black holes. If JWST and future telescopes keep finding those things, the framework gains ground. If they don't, it doesn't.
We started this episode with a provocation. What if the early universe produced uranium directly, through geometry, not through stars? And what earthformation.pdf is arguing is that this isn't a wild speculation. It's a geometric inevitability of a torsion-dominant early cosmos. The universe didn't start simple and get complex. It started geometrically complex, and we've been reading the story backwards. That's the kind of idea that either gets confirmed by the next decade of telescope data or gets ruled out by it. And either way, it's worth understanding. Thanks for being here on Copilot Podcasts.